All right, in the first half of the lesson, we were talking about what happens when you have a rational function, which is a polynomial over polynomial, and what happens when you get towards the end. You did a whole Desmos activity on that, and we're going to talk about that in a live session tomorrow. The second half of this lesson is what happens if your function is not continuous. In other words, what happens if it just abruptly stops. The discontinuity you've seen the most has been vertical asymptotes. We're going to talk about holes today too, as well. I'm going to show you an example of one of each. There are other types of discontinuities. There are slant asymptotes. We are not going to get to those. So for today, all you're going to need to worry about is holes and vertical asymptotes. All right, this is actually problem 4-66, and there are two parts, f of x and g of x. Let's go ahead and factor this guy. This becomes x plus 2 times x plus 3 over x plus 1. And g of x becomes x plus 2 times x plus 3 over x plus 2. If you notice, there is a giant 1 in g of x. And that just becomes x plus 3. It's just the line. However, if you think about it, you know there's going to be a discontinuity whenever your denominator is 0. So something's going to happen here at -1, and something's going to happen here at -2. And let's take a look at those. Down. If you graph both those functions, what you end up with is this function is going to have a vertical asymptote at -1. And this line actually will not exist at x equals -2. And what's going to occur there is a hole, just a big hole. That's how you would graph it. Just this line, all of a sudden there's a hole, and then there you go. Keep going again. All right, the deal is on any graphing calculator or any graphing program, it will not tell you which type of discontinuity you have. You have to recognize which one it is. And you know you're going to have a hole when you have this giant one. And you know you're going to have a vertical asymptote when your denominator becomes 0. So here at where x equals -1. So I've written that down here. Because it will not tell you. You're the one who has to think about it. And you're going to have a hole when the function has a giant one like g of x. And you're going to have a vertical asymptote when the function is 0 in the denominator. So those are the two you need to worry about. You're going to do a couple more problems working with these guys. And just keep those two facts in mind, and you'll be good.